Good day, everyone. My name is Adibelo Latovi. Welcome. I know that you've been following my playlist already, and this is the third map we'll be treating. Okay, this is a geological map, but in this map, there's one thing unique about this map is that it has two cross sections going from A to B and C to D. Okay, and so in this map, we're going to draw two cross section for this map. So I'll explain how to go about drawing for the second cross section. Okay, yeah. So now AB. So you are going to draw for cross section AB, you draw for cross section CD. Good. Now if you look at this map, anytime you see a map, you must be able to analyze it. If you look at this map, one of the things that you see is there is a dip. But can you see a spot height here? Can you look at it clearly? Can you see a spot height? No, you cannot see a spot height. A spot height is not here. Okay. So what does it mean? It means that this kind of map, every geological bed in this map have the same elevation, which means the topography is the same undulation, which means it is not dipping, like not in the manner of dipping, like they have the same undulation, the same height, something like this. It's like an area where erosion has not really shaping the topography to an extent. Okay, so something like this, where if you come here, it's still 40 meter. If you come here, it's still 40 meter. So unlike the ones that we have where you something like this, okay, you see that erosion has what? Has shaped the what? The topography of this region to this kind of shape. While in this, the effect is not really that evident in that all the beds are of that particular elevation. Okay, the cross section, that's it. Everything are the same. Okay, now let's move on. Now, focusing on AB, we're going to start with AB. I'll just give a short clue about the AB. Good. What do I say first? You're going to take your graph. You have your graph, and you need a slip of paper. You need a slip of paper. So I'm going to use this. I'm going to use this. So I'm starting with AB. I told you I'm going to draw two cross sections. I'm starting with A, B. A, B. So we have A and we have B. Good. Then you mark. So since they're not spot height here, we just jump the ladder and what? Mark the what? The boundaries. The boundaries. Can I write in B? Boundaries. The boundaries between the bedding plane. Just be able to note them. Okay, you can see this side. This is different from this. Okay. Under boundary. Under boundary. Then all of this is a bed. Then you have boundary, 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 boundary. You have a small like corner, boundary, boundary, then boundary. Okay, we're done. Good. Then I've said before in the earlier videos. So in this, the graph might not be able to contain it. So most time I usually like to use A4 paper, but okay. So I'm going to use the horizontal form of the graph. A, B, A, and B. Good. That's that. You take your ruler, then you rule. You join your A to your B. You write it. Don't forget you must write it A, B. There's mark for that. Okay. So the next thing is your what? Your scale. As I said in the previous video, your scale is very, very important. And you only exaggerate actually when the scale is too small to even show the cross section very well. So in this what we have here, since everything is of the same undulation, right? The same elevation. So we say that what do we have here? The highest here is what? 30 meter. So in this type of scale, you can choose, so which means you're just going to pick just like this. You can use anything to represent your what? Your 30 meter. But you can choose to represent. You can choose to do what? Represent by saying that what? So in here, you know that what? You must stop at what? 10 meter, no matter any scale you're using. So we have 2.5 representing 10. So 2.5 representing 10 meter, right? So when we measured from 0 to 10, measure from 0 to 10 with our ruler, we got 2.5. So you come here, right? 2.5 centimeter representing 10 meters. Good. So normally, but normally you know that your box is just 2 centimeter, your graph, because it's a graph. But if you are using your A4 paper, you can just use 1 centimeter to do the exchange. Okay, 2 times 10, so you're cross multiplying. So let's say here is x now. Want to get what is here? You say what? 2.5 times x is equals to what? 20. So x is equals to what? 20 divided by what? 2.5. Good. So essentially you're saying what? 20 divided by what? 25 over 10. Right? So essentially you're saying 20 times what? 10 over what? 25. Are we good? So here essentially you are saying what? 2 times what? 100. Are we? 20 times 10 is 200. So you saying that 200 divided by what? 25. So you have what? 2 times what? 4. And the answer is what? 8. So 2 centimeter is equivalent to what? 8 meter. So you can see, in anything, always follow your what? Your scale. If you want to exaggerate from the scale given to you. Don't just assume or don't just guess. Although some people say you can guess, but I don't advise that. Okay, so now each box represents what? 8. So we're going to what? I told you that since they are same undulation, you stop at what? 30 meter. So come to your graph. So 2 represents 8, Abby. Here is 8. 2 centimeter represents 8 meter, right? So we're going to 30, 8, 16, 24, 30 what? Is it 32? Yes, 32. So in the same place too, you do the same thing. 8, 16, 24, 32. Good. Okay, you can see I didn't guess my scale. I took it from the what? From your map. So the next thing is that you remember when we have spot height or even contours, you what we do first is what? To plot the contours, you take a spot paper and put on it. But this one, we know that everything, the highest undulation is what? 30 meter, because there are no spot height on your map. So what do? You join 30. You know, since everything is 888, it's like 0.8, 0.8 increase. Okay, so this 32, the around here should give us um 31 point something. Then we can just pick it as 30 actually. You can pick it as 30. And pick it as 30. So just join here, join it, join this to this, join this to this, then say 30 what? Meter. You can clean your 32, 30 what? Meter. Just stop at 30 here and what? 30 here. Good. So we stop at 30 here and 30 at the other side. Next. Okay. Now we don't have spot height that will show us an undulation. We don't have color undulation. Undulation can be like this. But when a map doesn't have a spot height, everything will just be what? Like this, like a box. Okay? And the highest distance that we have is 45. You stop at 45. 45 at both ends. If this is AB cross section. Good. I hope you get me. So the next thing you're going to do is the boundary. Remember earlier, we marked the boundary of the AB cross section. Of the what? AB cross section. And don't forget, as I've said earlier, you must start from A, and go to what? B. If you do B to A, you fade your cross section. Okay, so let's mark each boundary. A to B. Okay, this is a tick dot, so I can find them on the boundary. Let your dots be that thick. Okay, good. Now, in advanced mapping, we will be saying deep angles, right? Okay, so I tell you that what this when you see a deep angle, you can see you are saying 45 degree, and your idea about deep angle is where is it deep into? There's nothing like north, northwest, northeast. I told you that what in the previous video, that is either deeping towards A or deeping towards what? B. Okay, so in this place the only angle that we have in the direction of what? A is what? 45 degree, and it's dipping towards what? A. You can see the arrow, it is dipping in the direction of what? A. Okay, so if I ask a question, that means for each boundary you are drawing what? 45 for each what? Boundary. So if I come here, so tell me, so you can ask yourself, as you've watched in the previous video, that which of the will I count from here or count from here? So which side will show dipping towards A? Which side will show dipping towards A? I told you that if this is AB, dipping towards A, it must slide to like this. That's if you want to remember, just imagine that you have a ladder and you put a tire on it. So how will it slide? It will slide downward like this, Abby. So this is what I mean by dipping towards A. If I say dipping towards B, on that ladder, I put a tire on it and it slides towards what? B. That is dipping towards B. So you come here. So you know where are you counting from? You count from here. Can you see? That's how to make it slide towards A. So this is 45 degree. Okay. You take a ruler, pick it from here. Good. You keep that 45 again. Okay. Actually, there's a triangular method when you have the same angle. So I can use a video on that video to explain that. Well, anyhow, I just love to just make sure that my stuff is accurate. And okay, so we have 45 degree on that one, 45 here. Can you see? Because everything is dipping towards. So you can see I'm just stopping at the 30 meter, not taking it above it. So you don't have to clean later. Okay. 45 again. Okay, I think there's a mistake here. This one is for the other one. This one is for this. Yeah, it's for this. And this for this. Actually, with a triangle, you can actually know how what a 45 degree will look like. If you have a set square, you can actually get that. So you are supposed to use your tractor to do this. So yeah, just keep using your tractor and you'll get done with everything. Okay, good. Yeah, so that's that. What you get will be something like this. I told you earlier, even if they name anything, you must put the what? The legend that's on it in your cross section. Okay, So from A, you see that you're having something that is shading and an empty space, shading, line, empty space. You keep doing that. This A, so all of it, everything here must follow that same format. Shading, so the straight line actually, empty space, shading. Can use a ruler to just make it neater than what I'm doing. Okay, so without further ado, I'll just, because you know what you need to do, don't forget again. You, the next thing after shading everything and getting the right name, you need to do your legend. They will give you mark for that. So you write the name, the way they are being deposited, the way you can see them. Okay, which is deposited first before the inclination. You start with their names like that, and you name them. Each one of them, you name them. Write their name outside. If here is Mal, you write Mal. If here is brunette, you write brunette. So, like that. Yeah. So after that, note, in any exam you are doing test, you must write the title. So the cross section, if you wrote map 7, you must write it. Cross section, write a capital letter, and you rule. In title block, you still rule. Cross section of, let's say this is map 5, you write map 5. Map 5. But since this video is, this is the third map, I'll write map 3. Good. Now, the major part is that it looks as if we've done this before. Yeah. The reason why I chose this map was because you have two cross section. And the second cross section, can you say something about it? In the second cross section, this angle, the arrow position, is not in line with the C to D. It's only what? Dipping towards A and what? And B. So what do we do? Now, okay. Now, which means there's an angle. We need to get an arrow for it. Since everything, we know that everything is dipping towards this direction. So we know that what? Everything must be dipping towards what? Towards C also. For the C to D what? Cross section that you will draw. I'll give you an assignment on that. Okay. So now, how do we get the dip for this? So we call it what? Apparent dip. Apparent dip. And the formula for apparent dip is what? Arctan, arctan tan theta times, like everything, tan theta cos what? Cos beta. Tan theta cos what? Cos beta. Okay. Tan theta cos beta. Let me write it clearer. So we have, you can call apparent dip as alpha. Alpha is equals to what? Arctan tan theta cos beta. Okay. Next, how do we get the apparent dip? You know, for A to B, we know that it's 45 degrees. So for C to D, alpha is the angle that we get. Okay. So theta is actually the real dip, which you get from A to D that you have. So here we know that theta is what? 45 degree, right? So how do we get beta? Beta is all what? Divergence. It's called what? Divergence. So how do we get beta? Simple. You just need to get the what? The angle between what? C, CD, and what? AB. So either you are going to measure this angle or you are measuring this angle. Anything you get from there is your what? Your beta. You measure this angle. How can you measure the angle? Simple. You use your what? Your protractor. So let it rest the midpoint, okay? And zero at the other side must be on CD. Then check how many angle between C to D. What's the angle between C to D? From what I'm checking, you can either check this part or check the other side. From what I'm checking in this place, C to D gives me what? 45 degree. So beta is equals to what? 45 degree. Now let's find for our apparent dip. Apparent dip is what? Arctan tan 45, cos 45. So I take my calculator, tan 45 times cos 45. Okay? Shift. So what will be shift tan answer? So we have 35.26. 35.26. So since we're using our protractor to draw our dip, we can say what? Approximately what? 35 degree. Okay. So that's it. You've gotten your dip angles. So in a way, we know that everything is dipping towards this direction. Okay. So now we have an apparent dip for C to D, which is 35 degree. So your if you have to do your cross section, so I'm just going to give you, I'm not going to sketch for that. Just going to give you an overview for that. So you view your slip of paper, let's say you have your slip of paper and you do C, D, and you have taken your scale, the same scale, since it's the same map, I know that everything must stop at what? 30 meter. 30 meter here, 30 meter here, because there's no other control about that. Okay? The next thing to do is to what? So for each of the stuff, you can see here, if you measure all the, this starts from here. After this, you have this dark, this stuff. So let's say you're having all of this. You've measured your boundary, Then it's 35 degree, dipping towards what? C. Okay? So you're having something, you have something that look like this, actually, at the end of the day. Okay. So we've come to the end of this map. It's a map that consists of two cross sections that are going to do. You've also learned about acquiring dip when you're only given a dip for a particular um, cross section and not the other. So you just need to just solve for the acquiring dip and apply it for the second cross section. Thank you very much for listening.